All right, so let's talk our way through this chapter. If you remember right at the beginning of the chapter, we began to talk about different ways to solve systems of equations. That is meaning you're trying to find, if you graph them, where two lines would cross. Now, sometimes two lines don't cross. Sometimes they are parallel lines. If they are parallel lines, then they are considered to be an inconsistent system of equations. Okay, and you would know if they're parallel because they would have the exact same slope. Okay, so in other words, if I had two equations and I said, oh, y is equal to 1/2 x plus 4, y is equal to 1/2 x plus 7. If you looked at that, even without graphing it, you would tell me that they have nothing in common. They're parallel lines. It is an inconsistent system of equations. And if I asked you for the solution to it, you would tell me empty set. Now, the way you got that is like that. Okay, you know that those are the same. If one of them is negative and one of those is positive, then they are not parallel. Okay, the slopes have to absolutely completely match up. What if, however, I had that? Oops, hold on, let me take the negative off. What if I had that? Okay, that means there's infinitely many solutions. That means they graph the exact same line. So you have to pay attention to whether they completely match up or not. So if I asked you for the solution here, you would just write infinitely many. Okay, which means every set of ordered pairs that's on one is on the other one because they graph the same line. Now we did most of our work in the ones that were consistent and independent. What does that mean? If they're consistent and independent, what does that mean? How many solutions do they have? One. Okay, that means they're going to cross. They're going to cross somewhere on your graph. Okay, the first way we learned to do this was by graphing. Okay, that was the very first way we started out solving our system of equations. Like Joseph said, I would always back up my graphing with using my calculator. Okay, you want to go in and you want to do second calculate, you want to come down to intersection and find their point of intersection. All right, I am going to give you one of these to try, okay? Let me give you one that comes out though. Okay, I'm going to put one up here on the board. I want you to graph it and give me my answer. Okay, so in other words, you're solving it. Don't forget though, the first thing you have to do, if that's a 3, not a 2. First thing you have to do is put it in a form that you can solve it in. In other words, y equals mx plus b. I'm going to have to let Michelle's video run because I don't know how to pause it and then go back to the same video. While you're working on it there, I'll work on it up here.
I didn't get the intersection.
Okay, are those the two equations that you got? Okay, let me see your calculator then. Oh, you put a minus there rather than a plus.
Oh,
Okay. Because you've got a -3 divided by a -6, which is positive.
got it.
Okay, so I do think that you'll get it that time through. Okay, I changed it on there if you want to do second intersection. So the first thing you're going to do is you're going to put it in y equals mx plus b form. Okay, that's a big one. Okay, so make sure your equations line up. Then you're going to sketch graph it, but your graph is really not what's going to give you the answer. What's going to give you the answer is you're going to go into your calculator under y equals, and you're going to put one of those as y sub 1, one is y sub 2. Then you're going to go to second calculate, come down where it says intersection, hit enter, keep hitting enter until it says at the bottom intersection. Okay, and it will give you the point of intersection being 1, 1. Okay? All right, that's one way to solve the system of equalities. That's, by graphing. Then we did algebraically. Now there's two things under algebraically. There's by elimination and there's by substitution. I would think your preferred method would be by elimination, but I might be wrong. Some of you would rather do substitution maybe. Let me give you one to try, and literally all it's going to say is solve algebraically. So you can choose which way. I'm going to check on the test real quick and make sure that the test is the same as that. So solve this algebraically. And while you're working there, I'll work up here. All it says on the test is to solve algebraically. So you can choose whether you do substitution or elimination. Okay, I worked it all out, I solved for the y. Now the one thing I will say is make sure you're multiplying each term by that. The one mistake that is quickly made is forgetting to multiply the last term by it. Okay, if you've done it correctly, those numbers should eliminate out. One, either the x or the y. Okay, so in other words, they match up, but they have opposite signs. So when you add them, they're gone. Okay? Once you get your answer for either the x or the y, then you plug it back into any of those 4 equations, and you solve for the other one. Okay, so we know by graphing, we know by substitution, we know by elimination. Do you need to do one by substitution? Okay, let's do one by substitution. Substitution is definitely not my preferred way. but it definitely works to do it that way. One that would be set up perfect for substitution is this one. And it would almost be crazy to do elimination on this. All right, solve that one by substitution. Remember? All right, you're gonna make this into your key.
Oh, yeah.
Okay, remember this?
Yeah,
And then you're gonna substitute it in down here,
okay.
okay?
Yeah.
So I'm gonna actually work it out while you're
Oh,
working
okay.
it out there. So Vivian, in other words, I don't put my x here, I put what x is
Yeah.
equal to, okay? Do what you got. Good? This down here is what can throw you off because you're like, it really doesn't even matter what that is combined to equal, but you can do it on your calculator if you want. But when I subtract 12 from both sides, I get a 0. 0 divided by anything is 0. Remember, 0 on the top is equal to 0. 0 on the bottom is equal to undefined.
I know what I did wrong. I didn't multiply the 3 by the 4.
You didn't distribute.
I didn't distribute. I just added the 1/2 plus the
Which
4.
you can't
and- yeah.
do because that has a y, okay? All right, then the fourth way that we did it was by Kramer's rule. Okay, now Kramer's rule might throw you off just a little bit because that's going to be one that you have to study. The rest of these you probably don't have to study. So I'm going to do one, let's do one together. And then I'll have you do.
on that one is when you're doing the x because it's backwards.
Right, right. And I do think that, but if you do enough of them, the pattern sticks in your head. You would never do it by letters, I don't think, which is the way that the book presents it. But I think you would do it by patterning. So looking at this one, and this required you to know how to find the determinant of something. So you can't do this unless you remember how to do that. So for the x, remember, and the y, the bottom is the same on both of them. So the bottom, you're going to find the determinant of 7, 2, 3, and 4. Okay, so this and this. And that's the same on both. So don't mess it up on one, because if you mess it up on one, you'll mess it up on the other one. So this is going to be a 28, because remember you multiply up, okay? Then you multiply up here. So I have a 28 minus 6. Okay, so I've got a 22 on the bottom of both. Now I will say, and this is not one that, I noticed this on the homework that you did, if like one of these is a negative, like if it says 7x minus 3y, then I've got to put that negative in front of that 3. Okay, so don't forget to carry the sign in front of it down here with it. Okay, then on the top for this, you start at the back, and it's like you're in China and you're reading backwards. So it's a 5 and a 3 and a 3 and a 4. Okay, then I find the determinant of this. This times this is 20. This times this is 9. So I have 20 minus 9, so I have 11. That reduces down to 1/2. Now, for the y, it's the first column and the last column. So it's 7 and 2, and 5 and 3. So it's 21 minus 10, which is also 11. So that's going to give me 1/2. So the point that these two cross at, if I were to do elimination on them, if I were to do graphing on them, if I were to do substitution on them, is 1/2, 1/2. You remember? All right, now how about you guys do one, okay? I don't know why sometimes they do the variables different than x and y, but it really doesn't matter. All right, solve this using Kramer's rule.